Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Ensuring Data Integrity in WSN through Zero Watermarking Technique for Reliable Transmission. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the effective technology that we have designed for handling the data over the wireless sensor network by maintaining its security. So this is basically a zero watermarking method that we are applying on the data which is transmitting over the sensor network through the sensors. So let's move to the video. In this video, we will cover certain things including the application areas where it can be implemented. Then we will talk about that what exactly the code is, how to execute the code, what are the software requirements for it. Then we will talk that what exactly the current system was, what are the problems identified in them, and what exactly we have proposed in the method. Finally, the experimental outcomes and results will be analyzed. Let's move to the application areas. As the topic name is the data transmission, the WSN, so it can be in the certain domains, especially where the security is one of the important concern. So for the wireless communication, either it is in the biomedical domain, for the smart agriculture, for the smart building, even the industrial based, even the car based systems, IoT, Internet of Things, where the data is transmitting from one place to another and remotely it can be accessed, which is a crucial one. So that need not only reaching on time, but as well as it should be protected and saved. So security domain, those who want to work in the security domain along with the data handling, this particular video is for them. So let's talk about the code. So we will provide you the folder name, this under which there is a code folder in which all the files has been placed. Along with that, you must have the MATLAB software with you. The MATLAB version that I am using is R2019A, so you can use 2015 or above, but make sure it should be a full version, not the trial one. So in order to run the code, go to the folder where the whole files has been placed, just copy the path of the folder and go to the MATLAB and just paste the path and press enter. When you will press enter, all the files can be seen here. Out of this, there are three files that you need to execute. One is traditional, which is basically the implementation of the current system. Proposed code, which we have implemented and the novelty that we have introduced. And finally, the comparison among the both at the same page so that the results can be analyzed. Now in order to run this code, the file is open and you need to run it. In order to run it, there is a run command over there. There is a play button. You just need to click over that and it start executing. So when you will click over it, you can see it can start executing and give you the outcomes in the terms of the different factors. So the factors we will discuss later on. I'm just minimizing it for now. So let's talk about that, what exactly the problem was and what exactly we are doing. We were referring one of the paper in which the zero watermarking scheme was given in the wireless sensor network. The problem with this system, what exactly they were doing, let's have a look to that firstly. They were sending the data from one place to another and then applying the different encryption methodology where they were just doing the embedding part by a secret key, and that secret key is basically a normal secret key generated by the user itself. So the problem that we have identified is that the key generation method can be more effective. Secondly, the data they are transmitting that doesn't putting any impact on the energy efficiency of the system. Thirdly, the accuracy and the reliability of the system should be improved. So inspired from that, what we have proposed, we have implemented the system in which we are proposing one of the technique in which firstly we are doing the encoding of the data whichever we need to transfer. So encoding will reduce the data as well as it will transform from one form to another. That is a kind of the encoding. And then we are applying the encryption with the Diffie-Hellman technique. So Diffie-Hellman technique for the key generation is used in order to encrypt the data. So ultimately, by applying the encoding scheme, data get reduced. That's why the sensor network which it need to transfer the data need to transfer less size of data, which will reduce the overall energy consumption and increase the lifetime. Secondly, Diffie-Hellman key generation method is superior to the basic key generation method, and that provides more security. So now let's have a look. So I already run the traditional model. You can see here, this is the structure that we have showed, that there are the number of nodes in the network, and X, this red is the sink basically. The clusters are formed in order to transfer the data, where the nodes are sending their data to their cluster heads, and further the communication from cluster to sink has been done. So after, when the number of packets has been transferred, you can see the average time consumption during the as per the packets will change. So the packets that we are going to analyze are of different size of 10, 20, 30, 40, 50 bytes. So here you can see we have varied the packet length from 10 to 98 bytes. So the result that we got from the traditional method was this. So here you can see these are in terms of number of packets with respect to average time. This is with respect to number of packets with respect to average time, data stream size, and finally the watermark stream size. So in the proposed method, what we have done in the existing method, whatever the paper has been done, initially we have implemented the method where the packet size is going reduced. Then we have initialized a network initialization, which was not shown in the base paper because they were not focusing on particularly on the network. But we have deployed it, and on the basis of the minimum distance we are forming the clusters. And in the data section, what we are doing, we are generating the data, and on that behalf energy consumption is shown by using the energy standard model. Here is the main part which was already done in the base paper, that they were involving three of the things, like data they were generating as per the packet length, then they were adding data length, occurrence frequency, and sensing time. So these additional three sections are being collaborated with the data and forwarded further, and in order to encrypt the data they were generating a random binary key and doing the XORing part. So this is what they have done, and calculating the time, that how much time it is taking for embedding and extracting all the things, and finally analysis has been made. In the proposed section, the upper section is quite similar because the strategy is given by us. In the proposed section, what we have done for the data part, we are generating the data, keeping the same information along with that. Along with that, we are applying RLE, run length encoding scheme, to encode the data, which will actually encode the data and reduce the size of the data. Then for the key generation, we are not using the normal binary key, we are applying the Diffie-Hellman key, so whose algorithm is given in this particular function. You can read about it and can refer it. So it is giving us the key, which we are further converting to the binary and then doing the XORing part in a certain scenario, and then calculating the same factors for the embedding as well as for inversing the process, so that whether we can check that the input data and the given data is quite similar or not, and finally doing the analysis in the same phase of like average time with respect to water generation time. Each and every factor is quite similar as of the traditional method. And finally, when we are comparing it, I'm loading the traditional results as I have saved it by using this command, and the proposed results which are saved by save prop command. And in the compare, and loading both traditional and the proposed results in order to show the results. So when I'm running the code, you can see the results that we are achieving are individual as well as the comparison of both the things. So you can see this was the proposed results where the actual packet size is shown, and after the encoding of RLE the packet size has been shown. So you can see in every of the scenario, the encoded data is less with respect to the actual, which is by obviously reducing the energy consumption. Here during the watermark time and all, obviously if data is going to reduce, the time consumption will be less. So you can see for the proposed method, the data bits are faster and the time taken by them is lesser. More packets can be transmitted at the same time. So further modifications are still possible into it. So for more details, you can contact us directly and can get the details. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, We offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.